Hello everyone, this is Cameron Smith from Techlogix here today to go through another webinar. Over the next 30 to 45 minutes or so, we're going to be looking at tools, and a big part of the tools are how we use those to troubleshoot, terminate, how we take a fiber optic system and make sure it's going to operate properly. Now, this is part of a course that we've taught for CEDIA for quite some time. Normally, we don't spend a lot of time dissecting the actual toolkit. We spend more time talking about how you design a system to make sure it's going to operate properly, and that's going to be a big part of what we're going to be going over today. But before we get started, I do want to note a couple of things. First of all, this is being recorded. Thanks to our friends at Elan this afternoon. You will have a lot of good content that you can share with other folks in your organization. Now, also, I want to mention that this is only part of a wide range of trainings on fiber optic technology. We do a lot of training here at Techlogix. You might have sat in on a couple of other sessions that we offer. If you do want to learn more about cable or connectors or couplers or how to design all of this kind of stuff that goes into making a system operate properly, we have that content. Feel free to reach out. We will get you the information that you need. Now, with all of that said, let's start talking about technology. And let's start the conversation around designing, because it doesn't matter if you have the right tools. If you don't design properly, you're not going to do you a heck of a lot of good. So we always say that installation starts with proper design. It's going to make your job much easier as you go into the implementation stage. Now, there's a couple of things that you want to consider when designing a fiber-based system. The first thing is whether we're talking about a retrofit or a new installation. And this is pretty important. And if you've sat on other sessions that we teach, you know that there are two different types of fiber, multi-mode and single mode. And these two cables have a very different core diameter. The size of the glass inside the cables is different. You can't take a big piece of glass and connect it to a small piece of glass. It's not going to work. They're two different diameters. So if you're going into a new installation, you can really pull whatever cable you want to pull, provided you're operating within the distance constraints and bandwidth constraints and things like that. Now, if it's a retrofit, you got to make sure you're pulling like types of fiber, meaning if you go in, they've got single mode fiber already installed, you really want to work with single mode. You want to pull that because it's going to connect to that older cable in the installation. So you got to keep the type of fiber in mind. There are two different formats. You can learn a lot more about that on the Techlogix website. We've got a lot of good training and videos and white papers that'll walk you through this topic. Now, you also have to look at how will the cable be used? What are you going to do with it? Is it network-based? Is it AV-based? Are you sending USB over it? All of these different things will help you determine the type of connectors that are going to go on that cable and the strand count, okay? Strand count is how many pieces of glass we have inside that cable. Now, connectors are important because there are different types of connectors that are commonly used in different applications and on different types of electronics. Now, all connectors, as you might know, they perform the same, meaning they're going to have the same bandwidth. They're going to send the same types of signals from point A to point B, but those electronics in the different industries and applications, they like different connection types. It's really the size and the form factor of that connector. But if you're getting a pre-made, if you're terminating in the field, you really want to identify how this cable will be used, because that'll push you towards a type of connector. Where will the cable be run? You know, it's very important that we look at specifying the proper rating on that cable. Is it plenum rated? Is it low smoke, zero halogen rated? Is it outdoor rated? All of these things will go into the optical cable. Now, here's the nice thing about fiber. It's non-conductive. That means that you don't have to worry about surges or static or interference or a lot of these issues that plague installation. Lightning, right? That's a big one. Fiber's immune to all of that. So these things all go into that optical cable, but depending on where you're putting it, the jacket rating will come into play. How long will that cable run be? This is also important because this goes back to that single mode versus multi-mode conversation. Any project, any cable run that has a distance exceeding 300 meters or 1,000 feet This is going to push you into that single mode product category. Single mode is designed for those long distance runs. So you got to keep that in mind. You got to have a feel for how long these runs are going to be. Over 1,000 feet or 300 meters, make sure it's single mode. Under 1,000 feet or 300 meters, it can be either single mode or multi-mode. And then finally, how are we going to manage this cable? You know, this is something that often gets overlooked by a lot of people who get started with fiber. They don't think about enclosures like wall boxes or rack trays or the other equipment that's actually going to mount this fiber optic cable and couple the cables together. But enclosures are important because they give you a place for a service loop. They protect the connections. Ultimately, they manage the small little strands that are inside that fiber optic cable, and you should always have enclosures in your project. Okay, so these are some of the considerations that we look at when we're starting the system design, but here's the most important thing, and this is something that a lot of folks don't understand. Frankly, I do a lot of trainings, right? I travel all over the world, literally all over the world, certifying people on fiber optic technology and applications and design and things like that. And even companies who have decades plus of fiber experience, and it's true, fiber's been around for a long time, okay? This category might be new to the AV industry, but it's not a new product segment. Fiber has been around for over 50 years, and there's been a lot of folks who've worked with it over the years. And it is surprising how few people understand the link budget, what a link budget is, how this applies to a system, and it's an incredibly important part of any system, especially during the design stage. Basically, understanding the link budget will make sure your application works. And this is particularly important for anybody who's going to use their cable for AV. Okay, I'll explain why here in a minute, and I'll explain why folks who've done fiber don't really get this concept. But first, let's make sure you understand it. So the link budget's comprised of two things, a loss budget and a power budget. And the easiest way to think about this is the loss budget is the amount of anticipated signal loss on a cable run, right? Just like in the copper world, you can look at how you've run your cable. Are there couplers and patch points? Have we spliced the cable? You can look at the cable path and you can estimate how much loss you're going to have on that cable run, okay? And there will always be loss, of course. You're always going to have some loss. And it's very important that you start to quantify how much loss will be there, because we can put that loss budget together with the power budget, which is how much loss your devices can tolerate before they don't work anymore. All electronics can tolerate some amount of loss, but there comes a point at which they simply won't work. Put these two things together. How much loss do I think I have? How much loss can I tolerate? That is the link budget. And the reason I say a lot of folks don't understand this concept is because they've used their systems, their fiber, for networking. And one of the cool things about networking is there is packet correction. Okay, part of that IP protocol is taking any lost packets, any part of that signal that's transmitting from point A to point B, if there's any loss in there, if there's any part of it that doesn't show up properly, well, what's going to happen is that the IP protocol is just going to wait till those signals get retransmitted, and it's going to put it back together. So loss equates to slower speed in the network world. Still works, it's just a slower speed. And for this reason, you can have a cable that maybe not perfectly terminated. Maybe it's got a little intermittent connection. That loss just translates into slower performance. And frankly, your customers might not notice that their systems are running a little bit more slowly than if you had a perfectly installed, perfectly terminated cable. But in the video world, we don't have packet correction. If we're transmitting HDMI, for example, if we're sending streaming video, for example, well, there's no packet correction. So it's very, very susceptible to any loss. If we have parts of that stream, the ones and zeros, getting lost or getting delayed, it's going to translate into signal drop. And for this reason, when we look at the power budgets across different applications, well, if we're doing HDMI, we're dealing with about 3 dB. If we're dealing with AV over IP, 3 dB. This is pretty sensitive to loss. You move into the networking world, well, depending on your different devices, it can be anywhere from 11 to 22 dB. That's very, very tolerant for loss. So where does this come from? Where does the loss come from? Well, it's really not the cable. Most modern fiber optic cables are very pure glass, transmit the signals very effectively. Your loss is coming from your connection points, your splices, your couplers, your wall plates, you know, the connectors, your patch cables. Anywhere you're breaking that signal, this is where your loss is coming from. And we can look at these different applications and we can start to put this together. So let's calculate this link budget. Let's actually look at this in process, okay? And here's a very common installation, right? We have a home theater. If you're doing residential installations, this probably looks pretty familiar. You've got an equipment rack, you've got an HDMI source. We want to run that to a remote projector. If you do commercial installations, we'll take the sofas out of the room, move a conference room table in. Imagine this is a house of worship, right? All we're doing here is we're moving video from point A to point B. We're taking that source from the rack, we're going through bulk cable, we've got a couple of connectors in line, we're going into a wall plate keystone, and then we're jumping out to a remote receiver. This application, we can look at this application and we can calculate these loss points, and we look at our loss budget and we find that it should be about 1.3 dB. Well, we know because we're doing video distribution that our power budget's about 3 dB. This installation should work just fine, right? 3 dB greater than 1.3 dB, this works. It's when we get our equipment all installed, you know, our cables installed, our wall plate keystones installed, everything's in the wall and connected, and we actually get out our tools and we start to meter this run, and we can start to actually quantify, is our link budget proper? Is our loss budget within our tolerances? And this is where tools start to become very important, because obviously there's two sides to this. One, you got to terminate cable, you got to install cable, you got to work with it. But the other part is you got to be able to certify the performance. You got to make sure it's doing what it's supposed to do. And that moves us into the second part of this training, looking at the tools themselves. How do we do this? Okay, how do we get started? How do we work with all this? And we'll go back to our installation here in a minute when we talk about troubleshooting and how to make sure everything works. But let's make sure you understand the key tools that we'll use in this installation, okay? So from a most basic level, what do we find in a traditional, you know, proper fiber optic toolkit? Well, we start with the Kevlar shears, okay? One of the nice things about fiber optic cable is it's incredibly strong. And if you've taken any other trainings with us, you know that these cables, even the pre-made cables, they boast pull ratings of anywhere from 100 to 220 pounds, okay? Very, very strong. And that strength comes from the internal fibers inside. The delicate little yarn inside is actually made with Kevlar, the same thing that goes into safety equipment, bulletproof vests. Well, this goes into our fiber optic cables. And as you're working with a cable in the field, whether you're cutting it off, you know, cutting it to length, or you're prepping it for termination, you got to use a proper shears, Kevlar shears, to trim that off. Can't use scissors, can't use a knife. Kevlar's too strong for that. So any kit that you're going to be working with is going to have a pair of Kevlar shears. Now, the second tool that we get into is the 3-hole jacket stripper. And don't get hung up on jacket, because this does more than just taking off the outer jacket. In the fiber world, especially when we're dealing with mechanical style connectors, these are the type of connectors most people use in the field, you got to prep that cable. And you prep that cable with the 3-hole stripper, okay? It has 3 holes in it. The large hole is designed to take off the outer jacket, okay? So when you get a cable, it comes in an outer jacket. And you got to get to the inner workings of it, right? The inner strands, the inner glass. And that's where the smaller holes in this 3-hole stripper come into play. The middle hole is what takes off the buffer. So when and you'll see pictures of this here in a minute, but when you take off that outer jacket, you get into the inner strands, well, that middle hole is going to strip off the inner coating. And then there's a really small hole in there depending on the type of fiber that you have, you may need to go a little bit deeper into that glass strand, and that takes the inner coating down even a further notch. So the 3-hole stripper is very important, very key tool for your arsenal. Okay, take off the outer jacket, prep the inner strand. Now we also have to work with a cleaver. A cleaver is what we use to cut the cable, cut the inner glass strand, okay? So the Kevlar shears cuts the whole cable. Precision wheel cleaver, what that does is it cuts the glass strand inside there. If anybody's ever seen a window get cut, right? You've seen glass get cut. Well, how do you do it? You don't take a blade to it. You score it and you snap it, okay? Fiber optic cable is the same thing. What a precision wheel cleaver does is it runs a diamond blade across the little glass strand and then it snaps it. And by doing that, it gives you a nice clean break, allowing any of the lasers that are transmitting through this cable to go from point A to point B cleanly. If we were to just take our Kevlar shears and snip the end of that strand and we looked at that cable through a microscope, what you find is it's completely crushed, just completely crushed. The cleaver gives you that nice clean break, no crush marks inside that cable. So the cleaver is going to be one of the most important parts to the installation. That is another tool that we're going to be using. The VFL, okay, this is a laser. This is a visual laser. This has a lot of different uses in the fiber optic world. We use this to do terminations. So this is going to light up our connectors, allow us to see the glass strand going inside that connector, give us a visual indication that we're terminating properly. It's also going to test those connectors after we've put them on to make sure that they're terminated properly. So the VFL has a lot of different functions. Now in the troubleshooting world, as you'll see here as we continue to move on, the VFL is also going to help us tone out our cables. It's going to help us see the cable path, see breaks in those cables. This is a very inexpensive tool that is absolutely critical to most fiber optic installations. This is part of any toolkit that you're going to be working with. You use the VFL quite a bit. Now, one thing that you want to note here, VFLs by nature are usually built for connectors and cables and couplers and things like that that have 2.5 millimeter connections. You know, to simplify this for you, those are your SC, ST, and FC style connectors, okay? These have a different lens size than the small connectors, the LC style connectors. So when you get a VFL, keep in mind that it's going to come out of the box ready for those bigger connectors. If you want to connect it to the LC, which is the one that we use in most networking applications, this is where the adapter comes in, the VFL adapter. Basically, this just takes your ferrule size and then shrinks it down to 1.25 millimeters. Again, this is something that you're absolutely going to want and need because most network applications, these are designed to use LC connectors, and you need that adapter to really bring that footprint down. So another tool that you're going to have in your kit. Now, as we start to look at different types of fiber, and you know, I think this is pretty important, when you talk in terms of tools, make sure that you're thinking in terms of having a toolkit that can be used on all kinds of different fiber. You never want to buy tools, in my opinion, that are going to be only useful with one manufacturer's gear. You know, and I'd love to tell you, look, you're going to buy a toolkit, it only works with Techlogix, great, only buy Techlogix equipment. But in the real world, you're going to go into a retrofit. You got to work with that cable. So it's very important that all of your tools are universal across as many makes and models as possible. And for that reason, your toolkit should also include a ruler and a marker, because depending on the types of connectors that you'll get into, you may need to do some measurement and some marking. And in the fiber world, we use the metric system. You got to make sure that that ruler has metric measurements on it. This is going to allow us to take that cable and actually measure the jacket length. Sometimes it's really important that we measure an exact amount of outer jacket removal. But typically what you'll see is you're usually measuring the strand inside the cable for when you're stripping off that buffer, when you're preparing it to go inside that connector. Measuring it can be very, very important. So make sure you have a marker and a metric ruler inside your toolkit. And then the final part of this whole conversation before we move into actually walking through the termination process is cleaning supplies. Not all fiber connectors require you to clean them, but a lot do. And this is another thing. If you're working with a lot of fiber, it's important to have some alcohol wipes, alcohol bottle on site, because that's going to allow you to prep the fiber depending on what you're encountering in the field. But just as importantly, it's very important that you keep your connections clean, the ends of those cables clean, the ports on your network switches or your video extenders. All of these things are susceptible to contaminants, right? The dust in the air, pollen in the air, oils from your finger. If you start to get these contaminants on the optical lenses, what will happen is you'll obstruct those lasers from traveling from point A to point B. That's a problem, because if you're obstructing the lasers, you're not getting clean signal. That equates to loss, that equates to intermittent signal performance. So having those cleaning supplies in your kit gets to be really important, okay? Even if the fiber cable itself and the connectors don't need to be cleaned, the optical lenses will eventually. So these should be part of the kit. Now, as we're walking through all these different components, right, is it possible to get an all-in-one kit? Absolutely. A lot of different manufacturers offer complete fiber optic termination kits, Techlogix included. You can get these from your friends from Milan. Think about this. It's going to give you everything you need in one nice case. This is a very common part for installers who are getting started with fiber optic equipment. All right, so let's talk about the termination process. Now, as we walk through the next couple of slides, I want to throw a couple of caveats out there. First of all, we're talking about mechanical style connectors here. Okay, there are different ways to terminate. You can take a class from us that's all about connectors, or we talk about fusion splicing and different types of connectors, and go through the formats and different cable types, all of the different moving parts to this category. But for today's conversation, we're going to look at mechanical style connectors. These are the ones that snap on the end of the fiber in the field. These are the most commonly used fiber optic connectors by integrators in today's modern AV installation. Okay, these terminate in about a minute. First time you do it, maybe 2 minutes, but as you get the hang of this, plan on taking about a minute to terminate each connector. So we are looking at single mode fiber in this example with an LC style connector. All right, so what do? Well, the first thing you're going to want to do is you're going to want to cut the cable. And by the way, you can watch videos, step-by-step videos of this process. It's hard to get that to work properly during these webinars, so we're going to talk through the steps. And then my recommendation is watch the videos. These things are like 3 minutes long. They will take you through these steps really succinctly, okay? So first thing we do is we cut the fiber, put the end of the connector onto that cable. Now we got to start prepping the cable for termination. This is where our 3-hole strip come into play. We're going to cut that outer jacket off. And usually you want to take 2 to 3 inches of that outer jacket off. It exposes the internal strand, okay? Now, if you've never seen a fiber optic cable, it's quite amazing what you find on the inside of it. You've got those strengthening fibers that are made out of Kevlar. In this picture, you see they're kind of, pushed off to the side. We're holding those in our fingers here, that yellow yarn-like substance. And then you got this optical strand. It is tiny, right? We measure fiber in terms of nanometers, okay? So in microns, this is a tiny little micron 9mm fiber optic strand in this single mode cable. And we've got to be able to take the outer coating off, and we do that again with our 3-hole stripper, okay? We're actually going to use the big hole, take off the outer jacket, and we're going to use the smaller holes to strip off that buffer. And really, whether we use the middle hole or the small hole is dictated by the type of connectors that you're using. Any connector that you buy should tell you what the cleave length is going to be, what the strip buffer amount's going to be. This is all, you know, across different types of connectors, different manufacturers. All right. And depending on those manufacturers, you may have to use your ruler or your marker. You may have actually a ruler that's built into your cleaver, because once we get past the stripping of the outer jacket and the stripping of the inner buffer, then we get into actually cleaving the optical strand. Remember, the cleaver is pretty important. It runs a diamond wheel across that fiber, and it gives you a nice clean break. It snaps that cable. The cleavers will often have rulers, so depending on your connector, it'll tell you, hey, measure at 24 millimeters, measure at 10 millimeters, 16 millimeters, whatever it may be, cleave it, now we're ready to put it inside of your connector. Depending on the type of fiber, depending on the type of connector, at this step, it's not a bad idea. It's usually a really good idea to clean it off. Make sure we don't have any oils from our fingers, any impurities. Okay, not all types of fiber requires this, but it's really a best practice to clean those optical strands at this point before you insert those into the connector itself. And let's look at that process, because this is really the hardest part here, putting the fiber inside the connector. And the reason I say that this is the hardest part is because if you're going to break your strand, this is one of the places that it's fairly common to break the cable and then have to start over. Now, here's the nice thing. Most of these fiber optic connectors, they're reusable. So you can re-terminate, you can practice, you can reseat the fiber. What we do at this point, now that the strand has been cut to length, it's been cleaned, it's been prepped, well, we slide it into our connector, okay? And a lot of these modern mechanical connectors, they have locks on them. In this particular example, and these are Techlogix connectors, by the way, what you'll see is you'll have the amber little tab. You see that on the top of the connector. When it's in the back position towards the fiber strand, it's open. That allows you to slide your cable in. Once you slide your cable in, you see proper termination. You slide that little amber tab forward. It locks that fiber in place. Now we close our connector and we screw the boot on, cut our Kevlar off, okay? This preps it up. We've got a nice finished termination at this point. So these are kind of the steps that you'll work through, how your tools work through this whole process. Again, it takes about a minute, 2 minutes as you're getting started. Watch a video on this. It's pretty straightforward. Anybody can do it. The nice thing about the mechanical style connectors is, as you're learning, these are reusable unless you're breaking off the fiber inside the connector, which it happens, but it's not altogether that common, you know, as you get a hang for this, okay? Now, one other thing I do want to mention here. I mentioned keeping everything clean. You see the fiber wipes. We wiped off that outer strand, but it's incredibly important to make sure those optical lenses are clean from dust, oil, contaminants, and that's not the fiber itself. That's actually the port on your switch. That's actually the end of your cable. And this is where pen style cleaners really come into play, okay? What a pen style cleaner does is it actually cleans the optical lenses on your equipment. They're very incredibly cost effective. I mean, you're in the US here, you're around $65 per cleaner. You get anywhere from 800 to 1,000 clean cycles from them. And it's amazing because what you'll do is you'll take that loss. Remember, we were talking about that link budget and the actual loss that you'll experience on a cable. If there's oil or dust or pollen or anything obstructing those lenses, you know, you'll find an installation where you're at 12 dB loss, 20 dB of loss, just really a high loss bracket. You'll clean it with these pen style cleaners and you'll drop down to within that decent range, you know, 1.3 dB, 2 dB, whatever it may be. So these are one of the best investments that you can make. It's also one of the least expensive tools in the toolbox. And again, you get 800 to 1,000 clean cycles. Now, the only thing that gets a little bit clunky with these guys is, remember, you've got different lens ferrule sizes depending on the type of connectors. So there's two different style pen cleaners. One that's made for the SC and ST and FC style connectors, and then one that's made for the LC style connectors. So you may need to get two of them, but still, you're at $120, $130 here in the US based on that pricing. All right, now there is another category of tools which are equally important. These are the test tools, okay? So what do we do when we have to troubleshoot our installation? When we've installed everything, connected everything, and our link budget's way out of whack. And by the way, how do we tell that our link budget's out of whack? Well, this is where testers, meters, optical generators, these all come into play here. So let's talk about that. Well, remember that VFL, the tool that we use to check our connectors, put our connectors on the end of our cable? Well, we also use this, as I mentioned, for troubleshooting. The VFL is really the first place that you're going to want to start. And this should be not only part of your termination kit, but that same tool should be part of your testing repertoire. Because when you find a lot of loss on a cable run or in an installation, first place you go are those connectors. Typically what we'll find is you will have one connector that is not seated properly, and you're going to want to undo it, put it back on that cable. That solves a good majority of installations problems. Now, that VFL can also be used to find breaks in the line. It'll visually light up that cable where the break will be. Not as much of a problem anymore. This used to be a bigger problem with fiber optic cable because it was fairly brittle. You didn't have the bend radiuses. But today's modern, what we call bend insensitive fiber, it performs very well. In fact, you're getting bend radiuses of 4 millimeters, so 3 millimeters, depending on the cable. Literally, fiber optic cables can be tied in knots and they don't break. So looking for breaks in the line isn't quite the same problem that we used to have. But still, VFL is going to be one of those really handy tools for troubleshooting. But if you're doing a lot of fiber optic installations, you're going to want to start to think about metering kits, okay? Fiber optic test kits. These will actually give you the true amount of loss in your installation, okay? If you do a lot of commercial, this is a particularly useful tool because in a lot of bid specifications, consultant specifications, we see this a lot in government projects and military projects. Well, anytime you install a fiber optic cable, you have to certify its performance. You have to certify that it's going to operate within that link budget or have a certain amount of maximum loss, okay? Can't exceed a certain amount of maximum loss. Well, how do you determine what that is? Well, you got to get out meters. And meters are going to actually let you certify that cable run. Now, there are a couple of things that are important here because people who buy meters, they look at it and they say, okay, look, I'm just going to plug these meters into both ends of my cable run. While you can do that, it's usually not recommended. We recommend that you use reference cables, and we'll talk through that here in a minute, because those are wear components. Those are components that get dirty and can be replaced. And that's going to allow you to really maintain that trunk cable, that main cable that you've pulled, keep it as clean as possible over time. So let's talk about the metering process itself. Well, first of all, it is important to note that these meter kits have optical light generators that are going to be specific to either single mode or multi-mode. Why? Well, because we have different wavelengths depending on the diameter of the actual glass. So as you get out your different generators, in some kits, one generator can work for both single mode and multi-mode. You just throw it into different modes of operation. A lot of kits, they're going to be different. Okay, it's actually less expensive to have two different generators in a kit, and just you have one meter that's looking for a wide variety of different wavelengths. Well, the first thing that you do is you power on your equipment. Okay, make sure it's set for either multi-mode or single mode fiber, depending on the cable that you have installed, and then verify that you have a continuous wavelength coming out of it. Not intermittent. You can put these in different modes of operation, just like your VFLs. You can put these in intermittent modes of operation. It's usually not a good idea for testing. The only time we tend to do that is if we have two different cables that we're trying to tone out, or we're trying to meter side by side. But in most cases, the easiest way to tackle this is make sure your light sources or your generators are in continuous wavelength modes. And depending on your kit to make manufacturer, you'll see all of this in the manual and the instructions. These things, I mean, as you can see on the screen, most of these are pretty straightforward devices. Now we want to get out our reference cables. The reference cables are small little patch cords that we're going to connect to our main trunk cable, okay? Now, before we do that though, we've got to zero out the system, meaning we've got to take that reference cable and we've got to connect it between the light source and our meter, and then we zero out the system. It takes the loss that's being introduced from that reference cable out of the picture. So now when we connect that reference cable to our meter, to our light source, we're now only measuring the loss on that trunk cable. Okay, the reference cables have been zeroed out. Reference cables are nice because they're cheap, they get dirty, they get broken. You know, things happen with the connectors. You can replace those for a couple of bucks. What you don't want to do is get in the habit of taking your main trunk cables and constantly patching them into, you know, dirty test equipment or dirty couplers or things like that. When you do that, you're just, you know, basically introducing contaminants into this brand new system that you've just installed. So these reference cables, this gives you a way to really wear down those connectors, replace it for a couple of bucks, as opposed to the connectors that cost a little bit more that go onto these trunk cables. So any metering kit should come with couplers, should come with reference cables. Use these guys. This is a pretty important part of the system, okay? But, you know, meters, they're straightforward. They're going to give you the amount of loss. They're going to let you really identify which cable path, because often you're going to be using two cables. You know, one cable is used to transmit signals and one cable is being used to receive signals. If you've got a lot of loss or you've got intermittent performance, it helps to be able to identify, well, is it the transmit cable or is it the receive cable that's giving us our problems? Meters help you do all of that. And then finally, as I mentioned, well, what do we do if we have loss? What do we do if we have dirty connections? Well, it comes back to those click style cleaners, those pen style cleaners. They're really easy to use. Now, yes, you can use alcohol wipes. Yes, you can use lint-free wipes. People do that in the field all day long. I personally like the click style cleaners because they'll actually save you money and they're super easy to use. Now, one other best practice that you should get in the habit of, anything that's fiber optic comes with dust caps. Whether it's the electronics, the connectors, the cables, keep those dust caps in place as long as possible. They will help you avoid contaminants getting into your system. As soon as you remove those, you know, anything floating around the air, they can start to get on those optical lenses. So keep those dust caps in place, clean the connections before you connect stuff. Certainly if you're working on a retrofit, pay attention to cleanliness, pay attention to, you know, optimizing and cleaning those older connections that have been installed for quite some time. All right, last thing I want to leave you with before we take some questions here, fiber optic cable bend radius, okay? I did mention one of the problems with older cable is you do run into breaks. You know, just over time, fiber wasn't as pliable as it is today. So if you're going into a retrofit where that fiber is maybe 5 years old, 10 years old, just handle it with care. You know, this is one of the things where we see people, they get themselves in trouble. You can certainly use the tools we've looked at today to terminate. You can certainly use those tools to work with these cables, put new connectors on, couplers, things like that. But make sure you're maintaining a bend radius on those older cables of 1 to 3 inches. If you exceed that, you do run the risk that you're going to break it. And one of the problems with fiber isn't necessarily that it snaps. In a way, you're lucky if it snaps and it's fully broken, because now you know where it's broken and you know you can replace it. What tends to happen with older fiber optic cables is you get microfractures, meaning that the cable will, just like a windshield, it'll get a chip in it. It'll get a little crack in it. But over time, that crack gradually expands. The cable gradually falls apart. It's incredibly hard to troubleshoot. It's incredibly frustrating. Now, modern optical cables, well, these are built with clear curve or SMF28 Ultra. You know, these are terms you may have heard in the fiber optic industry. It just means bend sensitive glass. Clearline SSF, this is a polymer clad glass, super strong as well. These modern fiber optic cables, they really deliver a much tighter bend radius. That's what most people are using today. So with that, I want to thank you for attending today. A little bit different than what we typically teach when it comes to fiber optics, but we do get a lot of questions on the tools and how we use them and why we use them. And hopefully you got a little bit of clarity out of the last 40 minutes or so. And with that, I'll turn it over to any questions that you might have.